because we use a Greek symbol just to represent the summation, okay? So when you're talking about the sum of either geometric or arithmetic, it can be summarized in what we call the sigma notation. All right, so we now notes are telling us that sigma notation is a very useful and compact notation for writing the sum of any given number of terms of a sequence, okay? So a sum may be written out using the symbol, this sigma, okay? Just like a flipped 3, which is the capital letter S within the Greek alphabet, okay? See, it indicates that you must sum, you must add the expression to the right of the summation symbol. Okay, so if we have this as our sigma, whatever appears here, that's what we're gonna be adding. Now, what is interesting is that there's always a limit, okay? The starting point and then the end point. That must also be taken into consideration. We have an example whereby if we have this sigma, the starting limit is I must be 1, and then the end limit must be a 4. And then this is what we must use. So in most cases, whatever appears on the right is the rule, okay? More like the TN or the formula that is being used to generate that particular pattern. Remember, it can be arithmetic or geometric. It is rarely a quadratic, okay? Or basically a combination of any patterns or sequences. So in this case where there is I, just keep on replacing these integers, okay? So you can start with 1, 3 times 1 is a 3, and then 3 times 2 is a 6, 3 times 3 is a 9, and then 3 times 4 is a 12. Now, you can notice that since the numbers are just very few, in other words, they can be counted quickly. You don't need any particular formula to use, okay? So just punch this into the calculator and then you get your answer there, okay? So in general, they're telling us if we have the sigma I is equal to x to the n, it will be tx plus 1, and so on and so forth. So it's like we just keep on increasing and increasing. So the index of the sum, the lower bound, the upper bound, ti is the term of the sequence, okay? Now, sometimes they can just give you something like that, and then they tell you x is 1, and maybe this is 10. And then they ask you how many terms are they within this progression or the sequence or the series, okay? There's a way we do that. So you get the upper limit, which is a 10, minus the lower limit, and then you plus 1, okay? It's not a must that you should always start from 1. It could be a 3 here, depending on what you have as your expression here, okay? So if it's a 3, how many terms are gonna be there? So it's gonna be 10 minus 3 plus 1, which means we're talking about 8 terms. Do not just subtract this and that directly. That would be wrong, okay? So they're telling us for us to get the number of terms in the series, which is n, you get the end minus the start plus 1, okay? The end, which is the 10 minus the start, which is a 3, and then you plus 1, then you shall have the number of terms. Okay, let's look at some examples. They're telling us to write the series, okay? 3 over 1 plus 5 over 2 plus 7 over 4 plus 9 over 8, up to n terms in sigma notation. And so what we're going to do here is first of all, determine the rules, okay? We need to find the general terms or the formulas that we need to use, okay? So I have 3 over 1 plus, we have 5 over 2. Okay, there's a plus. And then we have 7 over 4. Is that enough? Plus, let's see, 9 over 8. 9 over 8. Okay, so what I can see is that these are fractions, but we know that fractions have numerators and denominators, okay? So let me try to look at the numerators and see if they are creating some sort of a pattern. So we can see this is a plus 2, that's a plus 2, that's a plus 2. So which means the numerator is arithmetic. Okay, at the bottom, this is a 1. It's going to be a plus 1, a plus 2, a plus 4. Plus 1, plus 2, plus 4. There is no second difference, so it cannot be a quadratic. But if I divide 2 over 1 is a 2, 4 over 2 is 2. 8 over 4 is a 2. So which means it's a geometric, but with a common ratio. Okay, so this is a geometric with a common ratio of 2. Arithmetic with a common difference of 2. All right, so from the top, let me just determine the general term. So n minus 1 into d. So our first term is a 3. Plus, that's n minus 1 into 2. Open that up, it's a 2n plus 3 minus 2, which means it's just a 2n plus 1, okay? Then at the bottom, for the denominators, we're saying Tn is given as AR to the exponent of n minus 1, okay? And then our A is a 1 into the R, which is a 2 to the exponent of n minus 1, which can be given as just 2 to the n minus 1. All right, so I have to combine these two and get my expression. Okay, so I'll start with the sigma notation and say we're gonna use n from 1. Okay, why am I using n? Let me just call it x, probably. Okay, because they told us the last term must be n, okay? Or you can still use the n is equal to 1 and then n is equal to n, okay? So the top part is 2n plus 1 over 2 to the exponent of n minus 1, okay? So this is the sigma notation that they wanted us to do, okay? So if in any case we had, let's say, the value of the expression, let's say after adding up everything, then that would be written after the equal signs, okay? Let's look at this one. I don't know why it's question 4, but it's fine. They want us to evaluate for 3 marks, okay? Now, we're starting from a scenario where R is 1, but we are ending at a point where the R must be infinity. So when you see such a scenario, straight away, they are asking for the sum to infinity, okay? Now, how do we get the sum to infinity from this? Remember, the formula is A over 1 minus R. So we need to get the first term, and we also need to determine the common ratio. So what I usually do, just get a few terms, okay? Something like 3 or even 2, yeah, they will be fine. Just do the substitution, okay? So that's gonna be 30 into 3 to the exponent of 1 minus 1. We know that 1 minus 1 is a 0. Anything the exponent of 0 will be a 1, which means my first term is a 30, okay? Then if I use R as a 2, that's gonna be 30 into 3 minus -1. Okay, because 1 minus 2, which is a -1. When I divide, I'll have a 10, and so on and so forth. So I already have my A, which is a 30, and then my R can be 10 over 30, which is just a 1 over 3. And then what I'll do next is just punch this into my calculator after doing the substitution into the formula. All right, so I'll jot it aside and say that S to infinity is given as over A over 1 minus R. We said our A was a 30 over 1 minus a third. So punching this into the calculator, what are I getting? I'm getting a 45 as my answer. Positive 45. So which means the answer here is a 45. That's what they needed. Okay, this whole expression reduces to that. So just follow the steps. Just get any two terms, get your A, get your R, and then substitute into the formula. All right, then, okay, let's have a look at the question 3. They're telling us that if we have sigma notation from R is equal to 1 up to N, we're using 3 times 2 to the R is equal to this. They want us to determine the value of N, which represents the last term, or basically the number of terms within the expression. Okay. So still the same thing, okay? we know that this is a geometric. We know, okay? We need to determine the pattern. It's not really a big deal, but let's just do it, okay? So if R is a 1, that's gonna be 3 times 2, which is a 6. Then if R is a 2, that is 2 to the exponent of 2, okay, which gives me a 12, and so on and so forth. But we know that the general term will be given as AR to the N, okay? We know that the A is 3, but in this case, we have the A as what? A 6. Then R, they are giving it to us as a 2. So let's not take anything for granted, okay? Now, from that, but yes, if I use 3, that will be 3 times 8, which is a 24. All right, so what I can see is that this is a geometry, but our A is a 6, and then our R is just a 2, okay? Then, since it's a geometric, I'll go down and write down the formula for the sum of the geometric. So our Sn is given as A into our R is bigger. So I'll use R to the N minus 1 over R minus 1, okay? So what I can identify from the information given is that we are interested in just the R, the N, okay? Our R is already 2, and then we know that our Sn is 378. So let's do the substitution and see. So that would be 378 is equal to 6 into 2 to the exponent of N minus 1 over, all right, 2 minus 1, which is definitely a 1, okay? Then step number 1, I'll divide both sides by 6. Okay, so 378 divided by 6, it's giving me a 63 is equal to the N minus 1. I'm ignoring the 1. Then I'll transpose the 1 to that side, which is a plus. So 64 is equal to the N. And then I can use either logarithm, so I can use exponential formats, okay? We know that 2 to the exponent of 6 is 64. Okay, to the exponent of N. The bases are the same. You can drop them and focus on the exponent. So N is a 6. So that is how we would have obtained that. Alternatively, use your logs. You still end up with the same answer. Okay, someone will say, how do you use the logs, okay? So if we have a scenario like this, if you introduce logs on either sides of the equal signs, I'll use log base 10 on either sides, okay? So log 64 is equal to the log 2 to the N. We know that this N must come that side. So N log 2 is equal to the log of 64. Then divide both sides by the log 2 over log 2. So that cancels that. And then just punch that into the calculator. Oh, that's 2. And then that is 64. So you still end up with your 6. All right, guys, that is that. Let's meet again in our next discussion.